When human cognition lags behind technology. Rethinking control chaos and the limits of the mind. Human history has always been shaped by the relationship between tools and the mind. Yet in the contemporary era, this relationship is becoming increasingly unbalanced. Technological systems are evolving at a pace that far exceeds the capacity of human cognition to fully understand, adapt, and govern them. As data-driven infrastructures, artificial intelligence, and automated systems expand, a critical tension emerges between what humans can process and what systems can do. This gap is not merely a technical issue. It is a structural and philosophical problem that raises questions about control, responsibility, and the limits of the human mind. The acceleration of technological systems. Modern technological systems operate at scales and speeds that are fundamentally different from human cognition. Algorithms process vast data sets in milliseconds. Decision support systems integrate multiple variables simultaneously. Digital platforms operate continuously, generating and responding to data in real time. These systems do not pause, reflect, or rest. They are designed for constant operation and optimization. In contrast, human cognition is bounded. It relies on attention, memory, and sequential reasoning. Even under optimal conditions, individuals can process only a limited amount of information at a time. Herbert Simon, 1971, introduced the concept of bounded rationality to describe how decision-making is constrained by cognitive limitations and incomplete information. In a world of accelerating systems, these limitations become more pronounced. Complexity beyond comprehension. As systems become more complex, they also become less transparent. Machine learning models, for example, can identify patterns that are not easily interpretable by humans. Large-scale data systems integrate inputs from multiple sources, creating layers of interaction that are difficult to trace. This leads to a condition where systems produce outcomes that humans rely on, but cannot fully explain. Decisions appear rational because they are data-driven, yet their underlying logic may be opaque. Pasquale, 2015, describes this as the rise of the black box society, where key decisions are made within systems that resist scrutiny. This opacity challenges traditional notions of accountability and control. The illusion of control. Despite increasing complexity, there is a persistent belief that technological systems are under human control. Interfaces are designed to provide a sense of command. Dashboards, metrics, and visualizations create the impression that systems are transparent and manageable. However, these representations often simplify underlying processes. In reality, control is distributed across multiple layers. Designers create models, institutions deploy systems, and users interact with outputs. No single actor fully understands or governs the entire system. This creates an illusion of control. Humans feel in charge, while decisions are increasingly shaped by processes that operate beyond direct comprehension. Chaos and unintended consequences. When cognition lags behind technology, the risk of unintended consequences increases. Small changes in complex systems can produce disproportionate effects. Feedback loops, interactions between components, and external variables can lead to outcomes that are difficult to predict. In data-driven systems, errors can scale rapidly. A flawed model or biased dataset can affect thousands or millions of decisions. Because systems operate continuously, these effects can propagate before they are detected. Taleb, 2007, emphasizes the role of unpredictability in complex systems, arguing that rare but high-impact events can have significant consequences. In a technologically accelerated world, the potential for such events is amplified. Cognitive overload and decision dependency. As systems become more complex, humans increasingly rely on them. This reliance is partly a response to cognitive overload. When individuals are confronted with more information than they can process, they turn to systems for guidance. Decision support tools, recommendation engines, and automated processes reduce the burden of analysis. However, this dependency introduces new risks. When decisions are delegated to systems, human judgment may become secondary. Over time, individuals may lose the capacity or confidence to question system outputs. Kahneman, 2011, distinguishes between fast and slow thinking, highlighting how reliance on intuitive or automated processes can lead to errors. In a data-driven environment, system outputs can function as a form of external intuition, shaping decisions without critical reflection. Power in the age of cognitive asymmetry. The gap between human cognition and technological systems creates a new form of power asymmetry. Those who design and control systems have greater influence over how decisions are made. Technical expertise becomes a source of authority, while others depend on systems they do not fully understand. This asymmetry is not only technical, but also political. It affects who can question decisions, who can access information, and who can shape outcomes. Zuboff, 2019, highlights how data-driven systems create asymmetries of knowledge, where organizations possess detailed insights into behavior, while individuals have limited visibility into how they are analyzed. In this context, power is exercised not only through decisions, but through the structure of systems that produce them. The limits of the human mind. At the core of this discussion is the question of limits. Human cognition evolved in environments that were relatively stable and manageable. It is adapted to process social interactions, physical environments, and sequential tasks. It is not naturally equipped to navigate high-speed, high-complexity digital systems. This does not mean that humans are incapable, but it does mean that there are constraints. Ignoring these constraints can lead to systems that overwhelm rather than support human decision-making. Recognizing the limits of the mind is essential for designing technologies that align with human capacities. Rethinking control and governance. Addressing the gap between cognition and technology requires a shift in how systems are designed and governed. First, transparency must be prioritized. Systems should be designed to provide meaningful explanations, allowing users to understand how decisions are made. Second, human oversight should remain central. Rather than replacing human judgment, systems should support it, providing insights while preserving the ability to question and intervene. Third, complexity should be managed. This may involve simplifying models, limiting scope, or creating layers of abstraction that make systems more understandable. Fourth, governance frameworks must address accountability. Clear responsibilities should be defined for the design, deployment, and outcomes of systems. A data justice perspective. From a data justice perspective, the gap between cognition and technology raises key concerns. Representation relates to how individuals and communities are modeled within systems. Simplified representations may not capture complexity. Distribution concerns how the benefits and risks of technological systems are allocated. Those with less capacity to understand or influence systems may bear greater risks. Governance addresses who controls systems and how decisions are regulated. Concentration of control can exacerbate asymmetries. These dimensions highlight that cognitive limits are not only individual constraints, but also factors that shape broader patterns of justice. When human cognition lags behind technology, the consequences extend beyond efficiency or performance. They affect control, accountability, and the stability of systems. The challenge is not to accelerate human cognition to match technology, but to design systems that respect and accommodate human limits. This requires a shift from viewing technology as an autonomous force to understanding it as a human creation that must remain aligned with human capacities and values. Ultimately, the future of a data-driven world depends not only on what technology can do, but on how it is integrated with the limits of the human mind.